Here is our last example. We are going to be solving for theta. So this really means the same as the previous examples. We're going to solve theta, where theta is in the set from 0 to 360, including 0 and 360. So we're just going to solve for theta. That's anywhere between 0 and 360, including those two values. This has a different flavor to it, that it has two trigonometric ratios. So just as before, we're going to solve for the trigonometric ratio. You can press pause and factor and see if your next step matches mine. Pause. All right, unpause. There we are. We are going to do the next step. What I recognize here is that there is a common factor of cosine in both terms. So I'm going to factor out cosine theta, and that leaves me with, now when I say factor out cosine, I get that it looks a little bit like magic, but what would this term be? Now factoring is very similar to dividing. So sine theta times cosine theta, if I'm factoring out cosine theta, the way that I think about it is, what would this be if I divided it by cosine theta? All we'd be left with is sine theta. Same thing over here. This term divided by cosine theta would be just -2. So that factoring has very close connections to dividing. Anyways, let me just continue, make sure that I'm right. If I multiply this out, will I get this expression? Indeed. So my factoring job is quite good. So now I'm going to use the zero product property of two factors, 1 and 2. I have to equate both those factors to 0 to use the zero product property. So cosine theta is equal to 0. Same with sine theta minus 2 is equal to 0. Our first factor is already solved. I'm going to isolate for sine theta. Sine theta is equal to 2. All right, stop and give it maybe a 5-second think here. I'm about to embark on a world of frustration. Take out my calculator. Perhaps I'm not thinking on autopilot in math. So I am going to do inverse sine of 2. My calculator says error, domain, whatever that's supposed to mean. So let me try that again. So let's make sure that my algebra is correct. So if I apply inverse sine to both sides, yeah, then okay, let me try that again. So inverse sine, inverse sine of 2, error. Believe it or not, I was actually trying to be nice here. Let me just solve the question. I'm going to exclude this, and I'm going to put an arrow through it to show my knowledge that I know this has no solutions. Now, it's only this section here that has no solutions. Over here may still have solutions. So where is cosine theta equal to 0? Now I'm going to solve for that factor. You know it. I draw that nice little unit circle. Where's cosine is equal to 0? Well, wherever x is equal to 0 along the x-axis here, up there and down there, you have your unit circle, presumably in front of you. So that means that all I have to do is identify those two angles. Up there is 90 degrees. Down there is 270 degrees. Forehead, nose, chin. That's how you make those brackets. And that's all there is. That's the solutions. So allow me to talk a little bit about this. Why was there no solutions? So remember that sine theta had to be between -1 and 1. Now that comes from the sine curve when we did it, right? So in other words, if your sine value is not between -1 or 1, there will be no angle that solves it. So if you took a look at the sine curve, the highest that the sine curve made, no, that was a terrible sine curve. Don't tell any of my math friends there. The highest that it went was 1. There is no angle that has the sine value that is 2, for instance. Also, when we drew the sine curve, the lowest value that it can have is -1. Same with cosine. So if you have a cosine value of 4 or -4, you'll get an invalid output simply because there is no angle that has a cosine value or a cosine ratio of 4. Now, remember that fundamentally cosine theta, remember that way back when, cosine theta is equal to my adjacent over my hypotenuse. And we're dealing with right angle triangles. If a cosine angle was, if the cosine ratio of 4 was 4, you would say that the adjacent was 4 over a hypotenuse of 1. In other words, the hypotenuse was not the longest side. And we know that can't be for right triangles. It has to be the longest side. However, tan was fundamentally different. Tan is a tricky beast in many ways to graph, and you'll see this a little bit later, but I actually prefer dealing with tan other than these two. Tangent can go from -infinity to +infinity. So anytime I reach for my calculator, it'll always give me, provided that I'm doing things correctly, it will always give me an output. So this is terrible, but tan goes from -infinity to infinity. The notation of this is not very good. Nobody would really appreciate that in math circles. So instead, we write it like this. Tan theta is element of the reals. Tan can be anything.